on to the next supplement. This is where we start to get into like even more juicy details. All right, folks. So then this is sup talk. This is gonna be my segment called sup talk, like supplement talks, deep science. Like I need to in the recording, I need to like deep science, like modulate my voice, deep science. Next one. See, I'm gonna show up there. I wish they had blinds here. I could shut these because the sun's coming through, and I think to me at least it's messing up. Acme Supplements brand Cdp Choline. It's also called Citicoline, CITI. I think what I've seen is normally on the supplement facts panel, of a sole CDP choline supplement like quote unquote this, or on a nootropic or a pre-workout, you'll see it listed as Citicoline, CITI. I've seen it CHOLINE. I've also seen CITICOLINE, Citicoline. The actual molecule is CDP choline. So that stands for cytidine. Now, I've heard cytidine or cytidine. To me, it's easier to say cytidine, so I'm going to stick with cytidine. Cytidine diphosphocholine. That's what it means. I'm going to set that over there. All right, so positives and negatives. We'll go with that. Oh, actually, I think I may have a picture of the molecule that I can show you. Let me see. I don't think I need these anymore. I'm gonna close these out just so I don't get confused. Yeah, I actually have a picture of it. I think I got this from. Did I get this from Wikipedia? Yeah. Let me close this. All right, let me share my screen and I'll show you a molecule of it. And then obviously, yep, we're going to go all through it, get into the juicy details of it. I said we're only on the second molecule, and we still got one more, and I need to go over some corrections that I made. So we still got some good amount of information to go over, folks. But I think those of you who like the deep science, you like to drill down to the details, I think you're going to be very happy with the end product of this. All right, so here's a molecule of CDP choline. So you have, again, I'm going to try to describe it for maybe people listening. You have choline on the left. See, there's your trimethylammonium over here. And then you have cytidine or cytidine on the right. And then in the middle, we have two phosphate groups. All right. Phosphate being a phosphorus with 4 oxygens bonded to it. At least that's kind of a simple definition that I've understood from it. So let's kind of look at the molecule of CDP choline. Let me stop sharing. All right. So positives and negatives of CDP choline. Well, the first is, unlike choline bitartrate, CDP choline is actually made in the body already. As I'm talking to you now, as you're watching or listening now, or listening or watching later, as you're, Memorial Day, you're outside, enjoying barbecue, whatever, your body is making CDP choline. So it is made in a process called I've heard this, the Kennedy cycle or the Kennedy pathway, discovered aptly by Dr. Kennedy. I think it was in the 1950s or something like that. I actually have a picture of it, and I'll show it to you in just a minute here. So yeah, it is made during this process, during the process of the Kennedy cycle. So actually, let me bring it up. So actually, I think it'll explain it. It'll explain it better if I actually bring up the diagram here. Let's see, which one did I want to use? Yeah, this one I wanted to use. That one's later. Let me share my screen. And for anybody that's just tuning in, I'm learning this as I go. So what I plan on doing is next time I'm using Riverside FM, and this is not a knock on Riverside. I've done interviews using them. It's a wonderful product. I mean, it's very, very high quality. The way it does the recordings and everything, especially if you may not have the best of connections, it'll still make your end result, like if you're doing um, remote interviews and such. It makes it wonderful. This is the first time I'm dipping my toe into using it for live streams. So it's not necessarily Riverside. It's me. It's what we call in IT a layer 8 issue, meaning that it's user error. I'm trying to learn it. So I think next time I'm going to bring these up in a browser window and then share my browser window, because I think it'll come up more clear in it. But at least I think I'm going to describe it well enough to get the point across. So this is the Kennedy cycle. All right, you can see the intracellular and then extracellular. This is inside the cell. All right, or inside a cell in the body. So on the right, we have choline as the beginning substance, what this whole episode is about, choline. And at the end, we have PC, which is phosphatidylcholine. On the left, which we're basically 99% of this, we're going to be talking about the right side, choline to phosphatidylcholine. On the left side, we have ethanol amine. It's easier for me to pronounce it ethanol amine. I've also heard it. Sorry, got a phone call there. Let me turn off the, there. Turned it off, silenced it. And it looks like it's a scam call anyways. On the left, we have ethanol amine. Now, I've heard it pronounced ethanol amine because it's like ethanol and then amine. But it's easier for me to pronounce it ethanol amine. And at the end, at the bottom, let me just make sure. Yes, it's sharing it. Okay, cool. And at the bottom, we have PE, which is phosphatidylethanolamine. This is going to, the left side, the phosphatidylethanolamine, it will come up later after we've talked about Cdp choline when we get into the corrections I need to make from the previous episode on choline on my mind. So this will come up later. So we're just going to leave it at that right now. I'm not going to go any more details on it. So again, we're going to be focusing on the right side. So as you can see, let's see if it, it doesn't list it here. Oh, wait, no, sorry, it does. Right here. After we have choline, P-choline, then Cdp choline. And then we have phosphatidylcholine. So pretty much like the third step, the second step, the end result is Cdp choline. That's how it is made in the body. All right. Well, what's the purpose of this PC? And why is PC being made? Well, phosphatidylcholine is a phospholipid that is a component. Let me minimize this and then share. Oh, let me stop sharing for a second. It is a component of the membrane of our cells. I believe I'm correct in saying that it is the most abundant of the phospholipids in the membrane of our cell. So very important. And as you saw from the diagram there, our body uses choline to make phosphatidylcholine. So our body uses choline to make acetylcholine. Well, it also uses choline to make phosphatidylcholine as well. So that's why it's a vital nutrient that we consume either through food or through supplements. And this goes to show that I am very, very tired this morning because I planned on bringing a bag of Howard's Blend plant-based protein powder to promote it, and I forgot it. It's at home. Oh, well. But Howard's Blend plant-based protein powder, it's got choline as well. Probably a little small amount, but I think it does. All right, let me share my screen here. Share entire screen. Actually, you know what? Thinking about it as I'm bringing this up, I need to check. I'm not sure if Howard's Blend plant-based. Well, I'm sure it has some choline in it. Again, probably just not that much, because usually your best sources of choline are going to be animal-based products, even though they do exist in plant-based products. I need to check the label again to see if it's on there. Oh, well. All right, here we go. All right, so here is a picture of the cell, and then we have the membrane, this membrane around it. So we have the nucleus here, we have, mitochondria, we have the endoplasmic reticulum, which is always, I always love that word, endoplasmic reticulum. But this membrane surrounding the cell, that is made of fats, lipids, the most abundant of which is phosphatidylcholine. So that's why our body makes phosphatidylcholine, right? So in order to make the membrane of the cells, so extremely important. Without it, we're in big trouble. So I don't think I need that anymore. So I'm going to stop sharing my screen. Okie dokie. All right. So is there anything else I need to go over on this? All right. So let me bring this back. Actually, I can keep it off for a little bit. So the Kennedy cycle or Kennedy pathway, which, you know what, I'm going to go ahead and share it again. This here, make sure you can all see it. Yep, it's not coming up on my screen yet, so hopefully soon. All right, I think it's back up. This here, this is one way from choline to phosphatidylcholine, the Kennedy pathway. It is one way in which the body can make choline. Doing the reading, I believe there's a total of 3. There may be more. I only read about 3. The second way is what's called the Lands cycle, LAND''S. We're not going to go into that in this episode. The third way is the PEMT pathway. I believe that's phosphatidylcholine methyltransferase, if I remember it correctly. Pardon me, phosphatidyl ethanolamine methyltransferase. What does that look like? Phosphatidyl ethylamine and then phosphatidyl ethanolamine methyltransferase. Is that a coincidence? No, it's not a coincidence. They are related. All right. So that's the third one. We're going to talk about that pathway after we've talked about Cdp Choline. All right. So let me check my notes, to make sure I am not missing anything vital. Yeah, I think we're good. I think we're good on that. I think we're right exactly where we should be. I haven't missed anything, which is amazing for me because my memory is gone as I get older. I will soon be 46 years old. God help me. All right, so this is one way. Again, we have the land cycle and then the PEMT pathway. Those are 3 that I read about. There could be more. Again, if you all know of more, let me know, but those are 3 that I know about. All right, so now we're going to go through the steps of this Kennedy pathway. I believe since the Kennedy pathway is essentially both of these, choline to phosphatidylcholine, ethylamine to phosphatidylethylamine. Pardon me one second. We're going to focus on this right side here. These are both part of the Kennedy pathway. However, I believe the choline to phosphatidylcholine is called the Cdp choline pathway. I believe that's what it's called. So we'll go through this step by step. We start off with choline, obviously. All right. So then there is a molecule of ATP. We all know ATP if you've taken biology, basic biology, adenosine triphosphate. It is broken down into adenosine diphosphate. The phosphoryl group is added to choline. So basically they're bonded together. And I believe a phosphoryl group, is phosphorus with 3 oxygen atoms on it. I think there's more difference between phosphoryl and phosphate groups, but I think that's the big difference between the two. This reaction, chemical tango, whatever you want to call it, is facilitated by an enzyme called choline kinase. All right. So essentially, choline is phosphorylated. I believe in a previous episode of the podcast, I said it was phosphorylation. I added a Z in there. No, it's phosphorylation. So that basically means the phosphoryl group is bonded to the molecule. So choline then, because of this, becomes phosphocholine. So that is the first step. I believe this takes place in the cytoplasm of the cell. And I knew I was going to need that diagram again. I'm not going to bring it back up. Basically, the area between the membrane and the in the nucleus of the cell. That's the cytoplasm there. All right, second step. This takes place, I believe, in the nucleus of the cell. Your phosphocholine, your result from the first step, and then we have a new substance, cytidine triphosphate. Well, cytidine, you said Cdp choline was cytidine diphosphocholone. Yep, they are related. Yep, this is where it comes from. So we have CTP, cytidine triphosphate. Those two have the chemical two-step, whatever the tango there. They have their chemical reaction facilitated, or the catalyst for the reaction is an enzyme. And this always gives me trouble trying to pronounce it. Phosphocholine Cytolyl transferase. Boy, say that 3 times fast. Cytolyl transferase. Cytolyl. See, I can't even do it twice. Phosphocholine cytolyl. Phosphocholine cytolyl. Cytolyl. Yeah, you get the point. It's the enzyme that facilitates the reaction between phosphocholine and CTP, cytidine triphosphate. The end result is CDP choline. This is how CDP choline is made in the body during the process by which our cells in our body are trying to create phosphatidylcholine from choline in order to use the phosphatidylcholine to make the membranes of our cells. But we're not done. We still got one more step to go. So we have this CDP choline here, and I believe this last step takes place in the endoplasmic reticulum. It has a reaction right here. You see it here. This molecule is diacylglycerol, or I think it's also called I don't know, I forgot. There was another name for it, but I know this one DAG is diacylglycerol, or I've heard diacylglycerol. It has a reaction. The catalyst, the enzyme that's a catalyst for this reaction is choline phosphotransferase. Much easier to say than phosphocholine cytolyl transferase. Much easier to say. They have the reaction. You end up with phosphatidylcholine and this one here, CMP, cytidine monophosphate. Right? So that's essentially the first benefit of CDP choline is that, well, it's made in the body. So when you supplement with it, you're basically supplementing with something your body already makes. All right, so I'm going to stop sharing this. And remember, because this is the Kennedy cycle, this will come up later. This is the one we're talking about. I think this is the CDP choline pathway, this right side of it. Let me stop sharing. Minimize that. All right, I'm back. Let's see. Another benefit of CDP choline is that supplementing with CDP choline could, and that's in big quotations underlined, could result in a decreased amount. Rodney, yeah, I'm not even going to try to say that, sir. I've heard that for super whatever. You get, yeah, it's a long ass word, just like I have trouble pronouncing cytolyl transferase. But CDP choline could result in a decreased amount of trimethylamine production. Trimethylamine, that sounds familiar. Yes, it should, because right here, there's your trimethylamine there. we talked about earlier. Literally, it's nitrogen, so that makes your amine, but then we have trimethyl, 3-methyl groups, CH3. It literally would be, I think it's N, if you write it out like the formula for whatever, I think it's N, and then you have parentheses, CH3, close parentheses, subscript 3. So it's literally 3 molecules of methyl groups or 3 methyl groups and then a nitrogen. That's trimethylamine. So supplementing with Cdp choline could result in a decreased amount of trimethylamine being produced. Trimethylamine being an amine, just like what we talked about with Cdp choline. So in the previous episode, we talked about this, the idea of trimethylamine, and then also TMAO, which is trimethylamine in oxide. Basically, an oxygen is added to the nitrogen, and I believe that occurs in the liver. And what we referenced for last episode was that trimethylamine could result in a fishy odor. So I think it was referenced that their urine smells like fish, their breath smells like fish, which is what I'm told all the time. That's why the women run away and say, "Oh, your breath smells like fish." I'm like, "Oh, sorry, I got too much trimethylamine. I'm sorry." That's what you can use now, guys. You say, "I'm sorry, I got a buildup of trimethylamine. I can't help it. I got fishy breath, fishy breath or fishy odor breath." But I've heard that the body, like it excretes like a fishy smell. So it's not harmful. At least to my knowledge, it's not harmful, other than your social life is harmed by it. And what happens is it's produced by bacteria in our intestines that metabolize choline, and I believe carnitine as well. It can do it with it as well. But other than the fishy odor, which that could be a big deal to people, especially mentally, socially, whatever. The liver converts it into trimethylamine N oxide, which, good thing is it doesn't smell like fish anymore. Bad thing is it's not good for your body. It can lead to heart disease. I've heard cancer, diabetes, just a number of different chronic, illnesses can be caused by too much TMAO, is what it called, trimethylamine N oxide. So the idea is, or at least what I read, it said this is just hypothesized. It has not been proven. So I'm going to go ahead and mark it as a positive, a potential positive, is that Cdp choline could reduce the production, or could result in a reduced production of trimethylamine. And there was like maybe 2 or 3 reasons given, or possible reasons why that is the case. The one that made the most sense to me is that in the intestines, the cytidine diphosphocholone, it's still intact. So the cytidine hasn't been separated yet from the choline. It's still intact. So then it didn't say this. I'm only assuming on this that it's tougher than for the bacteria to act on it and to metabolize it to create this TMA. It didn't state that it stops it fully. It just reduces it so TMA can still be produced, which could then ultimately be turned into TMAO. But it could reduce it so then, maybe there's less of a chance of it building up. And I think in that same episode, I think it was, I don't remember the vitamin. It was riboflavin. I don't remember what B vitamin that is, but that it's possible that taking riboflavin could reduce or eliminate that fishy odor. So, all right. But that's going to be a positive because, you don't want a buildup of TMAO, whether it's, whether a buildup of it's going to cause you to have some sort of chronic illness. I haven't seen that confirmed or not. I think ultimately you just don't want a buildup of it. So if you reduce the amount of TMA, well, then you're going to be reducing the amount of TMAO. And the theory, or I guess I'm going to say the theory, for TMA and TMAO is this occurs if you're taking a lot of choline. So I mentioned with choline bitartrate, there was like that 3,000 milligram was like the upper, was like the max dosage that was provided in the documentation. Well, there's something also called the upper limit of choline in general. And I think it was like 3,500 milligrams or something like that. I've also seen that you may not have to worry about TMA all the way up to 7,000 milligrams of choline. So now this is not just CDP choline or choline bitartrate. This is choline in total. So this is the food you're eating, supplements, etc. So if if you hear this and you're concerned, you talk to your doctor, maybe whatever. If you're, especially, I would think if you're on something like a carnivore diet where you're eating nothing but like meat or eggs or something like that, or maybe a keto diet, then where you're consuming a lot of eggs, because eggs have a lot of choline, then that may be something you want to talk to your doctor about, see if they're concerned. I believe there's a blood test to see how much TMAO you have in your body. Maybe it's just something to talk to your doctor about. So I'm going to list it as a positive, because if it is indeed something to be concerned about, well, then CDP choline may reduce that and you're still getting your choline. Okay, another positive. Let me see what the, oh yes, I remember now. I was going to look at my notes and I remembered. Is regarding uridine. I think it's Uridine, not urine, uridine. Uridine is to keep it short, it's a non-essential nutrient. So our body makes it. I'm not going to go into too much on that because that would involve a whole bunch of more reading and then all these additional notes and everything, which I'm open to do maybe for a future episode. But it's a non-essential nutrient. Our body can make it, but it's also in foods, broccoli. I think it's in tomatoes, and it's also in organ meats. So organ meats again for the win. Organ meats are very, very healthy, assuming, for moral reasons or dietary reasons, wherever you don't eat animal products. But organ meats are very healthy for you. I have a lot of vitamins and nutrients, etc. in it. So uridine, wait a second now. We're talking about CDP choline. You're talking about uridine. What the hell does that have to do with anything? Well, in the body, cytidine or cytidine is converted into uridine. So if we bring back up, let me see if I still have it up here. Yes, I still have it up here. So let me share the screen again. Share. No, we're not going to look at my wonderful artist drawing of a capillary. It is sharing. Good deal. Here at the bottom, we have CMP, cytidine monophosphate. Now, I believe what happens here is that can be converted. This is just taking the example of the Kennedy cycle. Cytidine monophosphate could be converted into uridine. Uridine is converted into uridine triphosphate, which is then converted into cytidine triphosphate, which is what's needed for the second step of the Kennedy cycle to make CDP choline. So our body makes uridine already. The uridine our body makes, it's converted to uridine triphosphate, then into cytidine. So essentially what we're doing by taking CDP choline is you're increasing the amount of cytidine, because eventually the cytidine and the choline are separated. And then that cytidine gets converted into uridine, which then eventually gets converted into cytidine triphosphate. Now, uridine may also have cognitive benefits to it. It may be a nootropic as well. It may help to improve memory. It may also be cholinergic. Cholinergic meaning that it increases acetylcholine levels. This was also seen in one of the documentations I saw in aged rats. It was shown to improve memory, etc. And that I wanted to bring that up with the aged rats because I wanted to mention something real quick. I'm obviously not a researcher, so this. I mean, I'm not a scientist. I'm not doing this in the lab or anything, but yeah, there's a number of supplements, especially when you get into nootropics. Some of them are done on rats, and there are studies that are done on people. But there are some studies that are done on rats. One of the ingredients we're going to be talking about in the future is lion's mane. This is kind of off the top. I just figured I'd mention this quick, but one of the benefits of lion's mane is it increases like the brain-derived neurotropic factor. I think I'm pronouncing that correctly. But it actually causes like physical changes to the brain. So in order to validate whether that works or not, they have to decapitate the rats or the mice to actually look at their brain to see if it's actually physically changed. Well, I mean, Unless you want to go to jail, you can't do that on humans, living humans, and it won't work on a dead person because they're dead. There's nothing's going to change on that except for just their body slowly decaying. So there are, yeah, there's back and forth on it on, well, this has only been studied on rats or mice, and then how's that going to translate into humans? I'm not going to say whether that's right or wrong. I mean, obviously they have to change the dosage, um, between humans and mice, because mice have completely different metabolism, much faster metabolisms than people, and they're, obviously their weight's different and everything. I just wanted to throw that out there that, you know, yeah, yeah, preferably you want to do it on humans, but there are some rat and mice studies, and I mean that could translate over. That's just my 2 cents on it. Went way off topic there, but I just wanted to throw that out there that some of the studies that I read on this, they were done on rice. That'd be interesting. They were done on mice and rats, not on people. Or at least the ones that I read, they weren't done on people. So whether that means the benefits are going to translate into people, don't know. You have to experiment, but before experimenting, talk with the medical professional. I just wanted to bring that up. So uridine could convey some nootropic benefits, and by taking Cdp choline, we're increasing the amount of cytidine in our body. Thus, that gets converted into uridine. Thus, you could see the benefit of that as well. It's an indirect way of increasing uridine, if I said that right. So that's another benefit, and I think that is all for the benefits. So let me minimize this and stop sharing. So negatives. We'll go into negatives here with CDP choline. One negative is, I mentioned it during choline bitartrate, is the choline by weight, the amount of choline by weight is low. It's 18%. So if we have our Acme supplements, brand new label, collaboration between Wile E. Coyote and the Roadrunner, CDP choline, if it's 1,000 milligram capsule, then about 180 milligrams of that is choline. So less than half of what choline bitartrate is. Again, as I explained here, there's positives and negatives with each of these. So that doesn't make CDP choline bad. It just means that in terms of the amount of choline bitartrate has more than double than what CDP choline has. So keep that in mind. Another, well, this could be a positive or a negative depending on how you look at it. All right. CDP choline has a long half-life. Half-life meaning the amount of time that it takes for your body to metabolize like half of it. We talked about half-life with caffeine, and that I think usually for the most part, caffeine's half-life was like 5 hours or something like that. But there are people with genetic, I won't say abnormalities, but genetic variants, I'll say that it could take them, half a day to go through a half-life of caffeine. So if you take 100 milligrams, how long does it take to metabolize 50 milligrams of that? So for CDP choline, it's somewhere around 2.5 to 3 days for the half-life. So if I were to take this 1,000 milligram capsule this morning, let's say I took it this morning, Monday morning, I mean, it could be Wednesday evening before it gets to 500 milligrams in my body. My body's able to metabolize half of it, even up to 3 days. So it could possibly be Thursday morning before it's a half-life is reached. So that could be negative because if you're taking it every day, and again, this is just my interpretation of it. This is not in the research. This is just reading it. I'm like, oh, I'm thinking through my head, like potentials of this. If you're taking it every day, well, then that's building up. And then you may get to the point where even though, for example, we're talking about TMA, even though CDP choline may result in a reduced amount of TMA produced, well, if you're taking it every day and it's building up in your body and the half-life is so long, even though it's reduced production, it still may be a lot because you have so much in your system if you're taking it every day, which is one reason why people recommend, I recommend it too, cycle off of it for a time, let your body kind of recover. When you cycle off it, that's between you and your doctor, and that's it's kind of a personal choice. Me, I have my things, but my schedule, etc. But that's kind of the negative that I see from it, is that you could have this buildup of choline because it takes so long for it to break down. Now, you could also say, well, it's only 18% choline, so it's going to be a while before you build up a high amount of it. Right? And so that could be a benefit, is that, well, it's actually low in choline, less than half. So you have to take even more of it every day in order to, potentially maybe get to toxic levels of it. Now, it could also be a positive because if it's since it's such a long half-life, you may not have to take it every day. You could skip a day, skip 2 days, whatever, and you might still get benefits from it. So your supplements go longer. The bottle that you bought, it lasts longer because you don't have to take it every day. So I'm going to put that as a negative, but it could be a positive or a negative. All right. So kind of back and forth on that. With that, folks, I believe we've covered Cdp choline. All right. Cdp choline right there. Look at this awesome bottle. Great label. Again, took 2 to 3 graphic designers to make that. We're going to set it over here to be recycled later.